Okay, today's lesson we're going to look at transition matrices, which are used to predict what happens in the future based on what happened previously. So we set up a transition matrix and that'll be used to predict things, and they say from like state to state. So when they mention that, that could mean like it depends what the transition matrix is demonstrating. It could be week to week and month to month. They'll let you know what the transition is demonstrating. So that'll be in the question. So a transition matrix is always square. So that would mean, so the order is a 2 by 2 or a 3 by 3, etc. like that. So what happens is you'll have different things that are happening or places or whatever you're changing into, and that becomes how many you have of them is what your order will be. So in this example here, this was a car rental place, and it had a branch at Bendigo and it had a branch at Colac, and the cars were borrowed or rented or whatever, and then they're returned to a branch. So if you look, 80% of the ones who rent their car from Bendigo return it to Bendigo. And if you look at it, 90% of those who rent it in Colac return it to Colac. Then you have a little bit of extra if some 20% who rented in Bendigo will return it to Colac, and 10% who rented in Colac return it to Bendigo. So this is a transition diagram. So from a transition diagram, we can set up, a transition matrix. So if you look here, we can see this is a 2 by, here is a 2 by 2. So we have Bendigo. So if you look, we said from Bendigo, so you rented and you returned to Bendigo was 80%, and that was that 80% there. If you look at Colac to Colac, so if we were going from Colac to Colac, it was 90%, and we could see that there. That was 90%. Now, if we saw the rest, if you were going from Colac to Bendigo, so starting rented in Colac, went to Bendigo, we saw 10%. So you notice the transition diagram matrix, they put the percentages become decimals. And also we'll see that the columns of a transition matrix add up to 1. So if you add them up to 1, so the columns of a transition matrix will always add up to 1. So we can see why we have to change to decimals so that they'll add up to 1. Okay, so we can use, here's another way of setting up a transition, or not another way, but another setting up of a transition matrix using a diagram. So if you look here, we've got families in a country or town were asked what they did on their annual holiday. Each year they choose between staying at home, travelling, or camping. And here's a transition diagram to explain what happens. So from this, a transition matrix that provides the same information. So what we're going to do is if you have a look, we've got 1, 2, 3 like places or things that's happening. So that means we're going to have a 3 by 3 matrix. And so we're going to start with, we've got home. Now I'm doing home first because down here, that's what they've done. So all my options are the one way. So I'm going to say home, travelling, camping, and then down this side, home, travelling, camping. So sometimes it's easier to do the ones that are going back to themselves. So home and home. So you start at home and you go to home, that will be this one. So we know it's 30%, but we put it in a decimal answer. So then I might do the T to T, which is from T to T. So that's that one. And that was 50%. Sometimes it's easier to do the ones going back to itself again. So if we look C to C, C to C, so C to C is 60%, so I'll change that to 0.6. So then we've got to get the rest. So if I start at home and go to T, I get 45. So I start at home, I go to T, I get 0.45. Now remember, we said that these all have to add up to 1. So if I've already got 0.75, I know that this should be 0.25. And if I have a look, and I go to look, and I'm going from home to we're going from home to camping, sorry, I see that is 25%. That's what I got there. All right, so then we'll quickly do the rest. So if I go from looking at traveling to home, so I'm at traveling and I want to get to home, I can see that's 30%. Now, because I know that's got to add up to 1, so I know I'm already on 0.8, so that must be 0.2. So double to check, from traveling to camping, it was 0.2. Okay, and let's look at the other one. If I'm at, I'll just rub some of this out, getting a little bit confusing. If I'm at camping and I want to go to home, so I'm looking for that. I'm at camping and to home is 40%, so camping is 0.4. Now because this has to add up to 1, these two numbers already, so that one must be 0. So we're looking for this answer here, which I believe is actually B. So there's that answer. Okay, now that we know how to set up a transition matrix, we're going to use that transition matrix to find another state, or find out what happens in the next week or a couple of weeks' time, and so on. So generally when they will give you the original scenario, so if you have a look, they might call it the initial state, and we often write it as SO and whatever, and it'll be a column matrix. But the initial state is original scenario of what's happening, or originally what is happening. So you need something to find. So the way, if we were going to use our transition matrix, so if I wanted to get what happened after week 1, I would do the transition matrix times SO, and that gives week 1. If I wanted to do week 2, you can see I can use the transition matrix times S1. So essentially, to get the next one, the next one, or state, you times the transition matrix by the state before. So what we saw to get S1, that would be the next state, we did the transition times SO, which is the one before. So if I, for example, wanted to find S6, I might have used the transition times S5, the one before that, okay, if they gave it. So sometimes it'd be okay as long as if we're given the original state, so say SO and we're given that, but say they want us to get to state 20. Now, you don't want to keep having to go transition times and keep going all the way up to get to S19. That's going to take too long. So there is this rule here that we can use. So what it's saying, you can also get to state 20, say like down here. I could get to state 20 by using the transition and raising it to the power of 20 and timesing it by the original scenario. So if you have a look, so if you see the power amount and this number, they will add up to give what you want. So the reason I tell you that, because say you're given, so you know your transition matrix, and you've also been given maybe state 5. So you've been given this and you've been given this, and they want you to find state 10. So if I want to find state 10, this number and whatever power needs to add up to that. So it would be the transition to the power of 5. See, 5 and 5 give 10. So that's how you can work out. Now, you can only use, say, this formula here with the power trick when it's just a transition, when you're just finding using the state. There's no other bit in the formula. So we're really saying the way we get the next one is by timesing it by the state before. Okay, so let's go do some couple of examples. So here, a factory has a large number of machines. The machines can be in one of two states, operating or broken. Broken machines are repaired and come back into operation and vice versa. So here they say initially, so what they're helping you set up the SO. Initially there were 18 machines operating. So because they've said operating for 80, that must be operating and this must be broken. So when you look at your transition matrix, it must be in the same order in terms of OB, OB. So if we were interpreting this transition matrix, that little 80% says of 85% of the machines that are that operate one day are operating the next day, if that makes sense. Okay, so if you look, they want to say determine the number of operating and broken machines after 10 days. So really they want state 10. So we're going to go find that. So we can go, all right, state 10 equals our transition to the power of 10 times SO. So I've looked there and I know that I've got 10 and 0 add up to that 10. So we do the transition by the power of 10 and we would get our answer. Okay, so just to show you how this rule works, I've showed you, so here we've got the transition times SO and that gave S1. If we looked and we did the transition times S1, so I've put that one in there, we get S2. If we do the transition times S2, we get S3. So here's the answer to what S state 3 was. But just to show, if I do the transition to the power of 3 times SO, can we see how we get the same answer? So that shows you how. So therefore, I can go over into the calculator and type S10 to find S10, I'll do T to the power of 10. So I'll do this matrix to the power of 10 times the original scenario that they gave us, which was 80 and 20. So do the power of 10 like that. Be careful, once again, the order has to be the same, and just to have a look, your transitions should add up to 1, which they do. So that's just make sure that is correct, because you can only use this rule if it is a transition matrix. Okay, so if it didn't add up to 1, we shouldn't be doing this rule. Let's go. So here's another little example of transition. So they've set up a diagram over here, and they've said the chances of it, if it rains today, the chance it rains tomorrow is 0.7 or 70%. If you look at dry today and dry tomorrow, there's a 50% chance that if it's dry today, it'll be dry tomorrow. Okay, so what they'll do is so you can see they've set up a transition matrix here, and then you need to get the initial state. So what they might show, it shows that this one, they might say it rained on the first day. If it rained on the first day, you can see the chances of rain is 100%, which is why they've put 1 there and a 0 there. So you might not actually be given that. You might have to know that if they're saying it rained on the first day, well, you 100% know it was rain. So just put a 1 and there's 0 chance of dry. And then we can use this transition initial and find out. So you can see down here, they're saying S1 equals T times S2 and so on. We could keep going. Now, what you notice after a while, so this was if you look at day 7, it was this chance, so 62% and 37%. If you look at day 8, it's a little bit off in the decimals down here. But then finally, you see day 9 is the chance, and then you see day 10 is the chance. So what happens after a certain amount of states or transitioning, you get this thing called the steady state. So it doesn't matter what I put. If I put S11 now, I'm still going to just keep getting that number. So you eventually hit the steady state. Now, different scenarios, you will hit the steady state at different times. But a quick way to get there so that you know what the steady state is you just can always just raise the transition to a really high power and you're guaranteed to get there. So we like to do 50 and we'll just do SO, and that would give this scenario. So in that the one before with the operating and broken scenario, so we had operating and broken. I've raised the T to the high power times SO to get the steady state. So here's the steady state for that. So I could say eventually what this company would see is 25 of the machines operating or percent and 75% broken. And just to prove, when you have to prove at steady state, we really should do the one after so that we can see that the numbers are not changing and that we've reached the steady state. So it depends what they ask. If they said show, say for example, they said show that the steady state occurred at I'm just making this up, at state 10, what you would do is you would show that state 9, you had an answer, blah, blah, blah. Then you'd show that state 10, you get the steady state scenario, and then you'd also show that state 11 is doing the same steady state. So you're getting the same number there, you're getting the same number there. So if you had to show or prove, this is what you'd have to do. You just quickly type those out or write those out. Let's do the next question. In 2009, a school entered a Rock West Stedford competition. When rehearsals commenced in February, all students were asked whether they thought the school would make state finals. The students responded yes, no, or undecided, and this is shown in the initial matrix. So they've given us the initial matrix here. Okay, how many students attended the school? Well, you simply just add up all of those attendance. So we end up with 500 attended the school. Okay, each week the students are expected to change their responses. The changes in the response from one week to the next are modelled by the transition. So they've given us a transition matrix here, and then they've also given the diagram after it. So it complete the diagram writing in the missing percentage. So we have to write the missing percentage, which we can see is when you go from no to undecided. So I'm on no and I'm going down to undecided. So I can see that that would have been 0.25, so that's 25%, and I can add that in. Okay, the next part of this question, I've just copied the transition and the diagram to help us, so we know that's 25%. Of the students who responded yes 1 week, what percentage are expected to respond undecided the next week. So we're at yes. Now you can do it in a couple of ways. We can just do it on our diagram. So yes, and the percentage of going undecided. So we could say 5%, or you could have looked on the transition. So we're starting at yes and going to undecided, there's 5%. So the next question was, in total, how many students are not too expected to have changed their response at the end of the first week? So this is originally what happened up here with the SO. Now, if you think of the people who aren't going to change their mind, that would be 85% of the yeses, 10% of the undecided, and 40% of the no's, because they're the ones who are going to go back to that answer. So when you are looking at how many, so we're actually saying 85% of the yes plus 10% of the undecided plus 40% of the no's. So we'll have to use the amounts they give. So 85% can be 0.85 times yes, there was 160. Then we'll plus 0.1 times the undecided, which was 220, plus 40%, which is 4.4, times the no, which is 120. So you'd add them all up and that would be your answer. Okay. Evaluate the next question part. They want you to evaluate S1 doing transition times SO. So over here, I've popped in the transition and I've times it by SO to get it. So here's transition times by SO equals S1. So if you look, the power trick actually does work, because if you've got T, it's actually 1. So if you've got 1 plus 0, that gives 1, doesn't it? Also, I want you to note that if you add up here, we knew there were 500 kids here. At the end of week 1, there's no kids disappearing. So you should have these should remain the same amount in total. So if you look, those will add up to give 500 as well. So sometimes in your rounding, if something ends up being 0.5 and another one's 0.5, be careful, you have to have the same amount that you originally. So you might have to bump one up, bump one down, depending on it. So anyway, they asked for S1. So evaluate where S1 is and at the end of the first week. So the actual answer, I would be writing what I found, which was this. Okay. Then it says, how many students were expected to respond yes at the end of the third week when asked whether they would make it to the state finals? So we want state 3. So I've done the transition to the power of 3 times SO, and I've got week 3. Now we only want, now remember, if you look, this transition, this was yes, no, undecided. So this must be yes, no, undecided, and this is yes, no, undecided. So they actually just want they want how many said yes. So we just want this amount there, 361. So we'll write how many students are expected to respond yes, 361 students. Okay, so we are going to look a little bit more at the steady state, which I talked about before. So sometimes the steady state is called long term, or in the long run they might learn, or eventually the pattern becomes, that's just the wording they might use. That might be wording they use about the long term. All right, so we know we can get there if we raise it to a high power. So here in this scenario, this is the Rocker-Stedford scenario. I watched, if I raise this was the transition, and I raise it to a high power times SO, I get the steady state. So eventually, if they kept going, there's going to be 372 kids who say yes, 84 who say no, and 44 who say undecided. Now, for me to prove its steady state, I better do one after. And so I did it to the power of 51, and I showed that that's the same as well. Now, just say sometimes they give you just a transition and they're just the original amount of people. They might not say how they split up into the different groups. It doesn't really technically matter with finding the steady state, how the numbers are broken up, because eventually that's what steady state is. We're just going to reach the pattern. So you can look here in the scenario of that Rocker Stedford. I've done the transition to the power of 51, but this time I've pretended that the SO, I just put everyone, all the kids were undecided. So sorry, this was yes and no. But can you see I still got the same number? So whether you get given how the breakup is or not, as long as you've got the transition and how many people originally, you will get to the steady state. So we've probably got a couple more examples here, and here's one. So each week, 300 students at a primary school. So there, they've given me the original total amount. So essentially, whatever SO is equal to, they add up to 300. All these will add up to 300. So here they said they choose from either doing art, music or sport. So you can see that's across here and then that's across here. So when I eventually times by my initial state or whatever, it's going to be art, music, sport, like that. So if you read the question, based on the information above, it can be concluded in the long term. So I originally really wasn't given how they all broke up. So over here, I've just tried and I've put 100 in each subject and then raised the transition to a higher power, and I've got this answer. So I'm going to say 105 chose art. Now, if you look down here, if I round this one, this would be 86. Now remember, they all have to add up to 300, so I'm actually going to keep this one at 109. See how it was the 0.5? Now, if you notice, just to show you, so that got me to the steady state, just to show you, if I had just shoved them all in sport in the first week and still done the transition, you can see I still get the same steady state. So that's what I'm saying, as long as you know, it doesn't matter how you chuck them in. So if you go through these questions here, you'll see based on the information, no person chooses sport. Well, that's not right. We've seen 86 choose sport, so I'll cross that one out. All students stay in the same activity. No, they keep moving around, or they might some might move, some might say. All students will choose to change their activity at least once. That's not true. You might be just the person who always keeps going back to art. So that's not true either. More students will choose to do music and sport. Well, if we have a look, this is art, music, sport. Yes, more people choose music than sport. So this is the answer. Okay, with this next example, pretty easy. If the initial state matrix is this and the transit, find the steady state. So you can see I've done the transition to a high power times SO, and so if they said find the steady state matrix, you would just be writing out this one. We'll just round it, so I might say 76 and 59. Now see, just be careful if you add those two together, you get, what's that, 135, yeah, and that's the same as this one, 135, so we can't lose any, so be careful with your rounding. Alright, going on to, this was a question from last year's exam, so this is exam 2018. And this is setting up using a transition matrix. So you don't know, so they've got the diagram and they've got part of the diagram here, and they want you to work out what this value x is. So we sort of have to have a look. So if I'm going to start with maybe this one here, this section here, and what I'm looking at, this is obviously one of the points, and if you have a look, if you start on that one and go out, we have a 0.2. So I'm going to look along these and see if I start at one of these and if I go out, do I see a 0.2? So we can see there's two options there, and there's also one where you go out. So this month, 0.2. So let's have a look at something else. So I'm first going to try that this is point T. I'm going to see if this is T. So if you go from T to 1, so I might call that T. Now, we're saying T to T would be 0.2, so that could be 0.2. But then we're saying T to M is 0.2, so that would make this one M. Okay, for that to work then, I want to see when I go from M back to T, I get 0.1. So let me have a look. M back to T, I get 0.1. So that's looking good. Now also, so that's T. We want to see a 0.4 going out of M. So from 4 out to 0.4, that would make good. That works, and that makes that F. Okay, so if that's T, M, and F, then this one down here must be the last letter we haven't used, which is L. And the question that they're asking is to find the one that goes back to itself. So from L to L is 0.6. So I'd say that's the answer. So we could have a look. We could have started with, thought that this might have been F, but then it wouldn't have worked. So I just luckily picked the first one correctly. All right, so that was a little bit off track, just using a transition. We're mainly going back into steady state questions now. So if you have a look, there's 3 brands of chocolate. So A, B, and C. And they said initially there were 300 people using brand A, 250 and things. So they've given you an SO. So you can see that I've put that in here, A, B, C, and the questions asked in the long term. So that means we want the steady state. So because we want the steady state, I've raised it to a high power and I've found out. Now these are people, so I probably, each brand, so I'll probably round it up. So I say 4, 3, 9 for A, 2, 2, I'm going to say 7 for B, because I don't want it to be, because I'm going to round this one up, 309 for C. And we remember they just have to add up to the original amount of people there. So we had, so we need this to be a 7 for it to be the same amount of people as in the beginning. Okay, now this next question here, the oranges. When buying fruit in the winter, people alternate between oranges and apples. So here it's helping us set up our own transition. So it goes 75 of the people who buy apples will buy oranges the next time, and 55% of people who buy oranges will buy apples next time. So if you have a look, I've probably called this, apples and oranges, because 75 and say apples, oranges. 75% who buy apples today buy oranges next time. So you can see there I've put the 75, and 55% who buy oranges buy apples there. Now I've worked out the other two because I know they've got to add up to 1. I've made that 0.25 and that 1.45. So I know that. And then they gave me the SO here with telling me. Now remember, if I've done AO that way, I've got to do AO that way. So I've got the apples and oranges. And then because they've said in the long term, the actual question was long term. So I've raised it power 50 times. So we just probably make a statement that we have 87 apples, people buying apples, and 118 buying oranges in the future, in the long term. Okay, now this one, they've just said, this is just a basic question. They said if SO is that and transition matrix is that, then S1 is. So I have just simply done transition times SO, to get S1, 2 times that. And go to the next page. They've asked me to get they've given me S4 and asked me for S5. So we know we can always get the next one by using the one before, because that would be like a power of 1, and that's S5, which is what we want. So if you go 1 plus 4 equals 5. So that's like that. So that can help us with this next question. When they say calculate S5 using S3 and T, that means, well, what I've got is I would be timesing this to get S5. So they're saying use these two. So if I'm going to use the transition, this number and the power has to add up to that. So it will have to be the power of 2. So B ends up being the answer there. You're going to multiply that. Okay. With this next question, they were asked whether they want to receive an email or a hard copy, and in week 1 there were equal copies of hard copies and email versions sent to the families. So that is a way they have told you, like a SO scenario. Because they're equal, it doesn't really matter. And then they give you a transition, and then they're asking you what is happening in the long term. So if this pattern continues, what would happen? So you want to work out what the long or steady state is. Because we didn't give an initial one, but to see how it changes, I'm just going to put 100 in each. Now we're going to make it equal because they said to. So then I would just do the transition to a high power, so 50, times my SO scenario. Now remember, this is hard copy, this is email. And what you do, you'll find that this is such a minute number, you may as well say 0, and you'll see 200 sitting in there. So when you look at all the options, really what has happened, because this is hard copy and this is email, they have emails doubled. So the email versions of the newsletter have doubled in the long term. So you can see, because we originally started with 100, now we've got 200. So that's a good statement we can use. Okay, this last one was also taken from, it might not be in your notes, but it's an exam from last year, 2018, sorry. And here we go. Public library organised 500 of its members into 5 categories according to the number of books they borrow each month. So here are the categories. So here too, they told me that original amount was 500. So we know when, whatever the SO scenario, whatever it was with the J, K, L, M and N, they all had to add up to 500. So let's have a look at the question. It says, here's a transition, so I've got a transition. Now, in the long term, which category expected to have 96 a month? Now, we want to know in the long term. Now, remember before I said it doesn't really matter if how your original are broken up when you're looking at the long term, because whatever combination it is in here, it will end up the same when you get to the long term. So I've done the transition here to a high power, and I just chucked them all in the last one because it won't make a difference. So as long as it adds up to 500, so I just did them all 0 and 500. And we've got to the long term. Now remember, this is J, K, L, M and N. So to me, it looks like this one is the 96. So which one? K.